objective for this lesson is to write chemical formula for molecules with polyatomic ions. Now, this is a very similar process to what we did in the previous video, except we're just introducing this idea of a polyatomic ion. So to do that, first we actually have to quickly chat about covalent bonds. Now, it's a different type of bonding to ionic bonding, which we went into some detail about in explaining last lesson. But in simplicity, it's about the same process where an atom wants to fill its shells, but instead of giving and receiving electrons, they're going to share them. So we call this a process of like sharing. Sharing is caring, of course. So I've got here an oxygen and a hydrogen, and they come together, and you can see where their shells now overlap. So if you look at hydrogen's, for instance, you can see he now has 2 electrons in his outer shell without actually having to receive one from someone. He's sort of sharing it because his additional green electron is being shared now by oxygen. Now, based on their valencies, which work in a similar way to the ionic bonding, you can see that oxygen still does not have a full outer shell. So if we were now to have our good mate sodium come along, he's going to give away his electron, and as a result of doing so, that little molecule now becomes negatively charged, and sodium will become positively charged. So that little OH molecule there is what we call a polyatomic ion. It's a molecule with a net charge, and it's now going to join with other ions the exact same way we did with ionic bonding. So it does form an ionic bond here now, and we form now sodium hydroxide. Now, writing these chemical formulas does follow the exact same process, except there's a little fiddly few things to chuck in there as well. So we're going to look at barium hydroxide. So as we did previously, we write the chemical symbols and charge of the cation first and the anion second. So start with barium, which is Ba. We've got to find where he is on the periodic table, bottom left here, and he has, obviously, looking up, a valency of +2. So we're going to write that +2 in. Now, hydroxide. May not even know what the formula is for this, so we're going to go to our table of polyatomic ions. Find hydroxide. There it is down the bottom. It's OH. OH, and it has a charge of, or a valency of, -1. So we're now writing this as OH and -1. So just like we did previously, we're going to now transpose only the number of the positive charge to become the subscript of the anion, and the number only of the negative charge to become the subscript of the cation. Now, here's where it differs from what we did last lesson. If the polyatomic subscript is greater than 1, like in this case, we've got a 2, the polyatomic ion must have a bracket. So we're going to rewrite this as Ba1 bracket OH bracket 2. So it must encompass the entire molecule, the polyatomic ion. So if it was carbonate, for instance, CO3, it would be bracket CO3 bracket, and then the 2. So we reduce the subscripts to the lowest ratio. In this case, we don't need to do that. And obviously, if a subscript is a 1, it can be ignored. So we can do that in this case. So we end up with BaOH2. So what this tells us is for every barium, there are 2 hydroxide ions. Now, this is why it's really important to use those brackets. If we didn't have the brackets, it would read as BaOH2, and that would tell us that for every barium, there is an oxygen and 2 hydrogens. So we've got to be careful that we include those brackets so we're talking about the polyatomic ion. It is a really straightforward process, just like we've done in the previous lesson, so I don't think you have any dramas. Just work through those questions as you go.